Okay. Yeah, right. Great. Well, thank you everyone for attending this breakout session. I know there's some competition out there, both with other venues that are going on at the moment, but also competing with Richard Clark to some extent. He always seems to have the fun topics, talking about some of the sexier elements of security as it relates to government and cyber terrorism and things of that nature. But I think there's definitely a link here. As Chris mentioned, I'm Matt Moynahan, CEO of Veracode, and we're really trying to speak today less about Veracode, but around a lot of the elements in application security that many of you in the room are dealing with or have contributed to trying to solve over the past 5 or 10 years. I'd like to start out with an example, actually a real-world example that impacted me probably about 2 weeks ago. How many people have had a recall on their car for some reason? I think there's been a lot of things obviously out there, whether it be kids' toys or food or what have you, but just 2 weeks ago I had a recall on my Jeep, and it was interesting. I thought it was applicable to today's discussion. There was a security issue with my Jeep, and essentially what happened was Jeep said, you know, we'll pay for the entire problem, but the problem is this: if you're in your Jeep and you're going uphill at a certain grade, at a certain speed, your brakes may not work. I said, you know, interesting. I said, what do I do with that? You know, so I immediately, as a consumer, sat back and said, how important is this to me? You know, what's my acceptable risk profile for that? You know, how important is it to take time out of my day to go fix this? Ultimately, I decided it wasn't. I said, I'm just going to use the back roads, no hills for a while. I didn't have the time to go do it. And even though it was going to be a free recall, I didn't feel like getting a rental car and all of that. So clearly that was an example where it wasn't worth me to fix it. Now, had I known that about Jeep, if the salesperson said, hey, just to let you know, at a particular grade, when you're going up a hill, your brakes may stop, I wouldn't have bought the Jeep. I would have said, I'm going to go on to a different car. Even though, you know, I may have been able to absorb that risk, as a purchaser of that car, I wouldn't have bought it. And I thought it was very apropos to today's discussion, which is around the role of 2 very important processes that we all deal with as producers or consumers of software. You know, how secure should products be when you're buying them? What is your risk profile when you're buying them? How secure should they be when you're shipping them? And it really is all about acceptable risk, and those levels vary over time. In order to make some type of decision around that, you've got to have some sort of scoring system, some sort of metrics. And I'll talk to that today, primarily around how do you determine acceptable risk in an environment where application security risk is constantly changing. And what's an appropriate approach for that? And really, I'll speak to it from my own real-world example, managing Symantec's Consumer and Small Business Division, which at the time was about a 400 or 500 person division. We had about 200 or 300 engineers, and largely joined Veracode because of the difficulty in solving the application security problem. So very quickly, if you look at the software industry in general, there's a huge issue out there. This is largely, the term unbounded risk is used quite often in the financial institution space, but the software industry is probably the largest industry in the world, the largest manufacturing industry with no agreed upon metrics for security quality. There's about 350 billion in off-the-shelf software sold every year, 100 billion customized on top of it. There's 50 billion outsourced to India. There's 1 billion outsourced to China today, and no one has any idea how secure it is. Huge issue. Why is that the case? You know, part of it is around the metrics that we'll talk about today. In the past, and it's been fairly legitimate, many of the software organizations have used the market to essentially test their code. You develop something very quickly based on customer demand, you ship it, you find out, you know, what works and what doesn't work. Software companies respond and have this iterative approach to software development. Well, the market has so fundamentally changed over the past, you know, 7 years, where the threat of exploit has gone up. We've all seen it, whether it be stolen credit cards, identity theft, or what have you. We can no longer rely on consumers to test software for us. There has to be some notion of accountability and acceptable standards as we shift towards a model where the profile of hackers have gone from, as we know, script kiddies to organized crime, quite honestly, that have a ROI on their activity that's far greater than it ever has been. On the right-hand side there you see some statistics that you've probably all seen in the past. Most of them are from Gartner, some of them are from NIST, that basically say that the vast majority of vulnerabilities have moved from the network layer to the application layer. And that shouldn't be surprising to us, given that the applications are the ones sitting in front of the data, which is what the hackers and others out there are actually after. That's where the value lies, customer data. It's important to note that only 10% of IT security spend is at the application layer. The vast majority still exists at the network layer. And that's because enterprises move slower than hackers, right? And so that statistic actually comes from Gartner and other research analysts that still feel that the vast majority of spend is at the network layer, which is understandable. So just a quick slide here, won't focus on these, but no one really is spared. These are 5 examples of fairly recent breaches that have taken place with web-based applications. Anywhere that customer data lives, the attackers will go after it. There is money there, whether it's Barack Obama, Hillary Clinton's campaigns online that are reaching record highs as far as internet contributions, to the Colorado Rockies, to various auction houses, to eBay, et cetera. So really no one is spared. With this valuable data that's to be exploited, folks will go after it. And so what are the trends that are making all of us in this room, whether you're a developer or an enterprise trying to secure your applications, difficult? Well, you've probably heard from Richard Clark, economic globalization. Enterprises are not going to stop in their drive to improve their margins. Whether it's extending their enterprise and having an extended ecosystem internationally, whether it's leveraging India or China for wage arbitrage, if you will. The world is global, the world is flat, and that's not going to change anytime soon. Obviously, Richard Clark, I believe, spoke about some of the concerns around cyber terrorism, and that only is going to increase as applications are built in other locations. On the right-hand side, clearly there's a decreasing trust in cyberspace. The Internet was founded on trust. If you go back to the government and the academic institutions, in the very early days, you actually believed who was on the end of that email or that interactive session. That's no longer the case. And if you look at one of the greatest and fastest growing areas in security, it really has been around the identity access control space. Trying to identify and authenticate and validate who's on the other end of that transaction, whether it's your child's internet chat session or whether it's a business transaction, is a great source of risk because of the data and the transactions that are taking place. The lower left-hand quadrant about liability is a huge issue, right? In many cases, we're outsourcing development for our applications. You can outsource development, but you can't outsource liability. US-based organizations are not going to be able to go after organizations in China or India and be subject to the same court of law. And so while our software development process is getting more fragmented, more distributed, the liability still is very much close to home. So there's an issue here for US-based companies that exist just by the very nature of international and global software development. And on the right-hand side, it's clear that with government regulations, despite all this complexity, there's an ever-increasing need to be transparent. It's a complete opposite requirement, if you will. Trying to spread and distribute the software construction process, but at the same time trying to increase transparency are 2 very divergent requirements in the marketplace. This is a slightly modified slide from a government slide that I presented at the Software Assurance Forum last year, but you can really think about the software construction process or the software procurement process as being a distributed vulnerability supply chain. And really, if you step back, and even if I look back on my days at Symantec, and if I were to slice Norton Antivirus in half and get a profile view of that application, you would have seen 4 very distinct chunks of code. I was responsible for $2 billion in bookings, $2 billion in revenue for that organization, and I only wrote 25% of the code. And quite honestly, it was the least interesting portion of that application. I wrote the integration glue. I wrote the code that actually stitched a bunch of stuff together. Part of the code, 25% of the code, came from third parties inside of Symantec. The live update engine, the antivirus engine that were in the products came from some other group that built them and shipped them to me. It was binary code. 25% of my code came from India, where I actually set up an offshore development organization in Chennai, India, co-located with customer support, so that we could respond to customer issues very quickly. Made a hell of a lot of sense from a customer support standpoint, but my visibility decreased into that code as I pushed that offshore. 25% of my code came from third parties. If there was a feature that was important to my customers but didn't require my engineers to build it, I would license it. It's a common practice. I was shipped binaries and to integrate into Norton antivirus. And then most enterprises probably have a fifth source, which is open source. Pulling down reusable components and bundling them into an application. So if you look at an application, there's multiple things going on in there. In most applications today, unless you're some of the largest software companies that have a very controlled application development process, you really probably are sourcing 50 to 60% of that application from other locations, whether it be other departments or third-party sources. And so I think the first step in trying to create some sort of model needs to look at all of these sources and types of the security risks that exist in your applications. It's not good enough just to look at your own source code, because it's almost as if Moody's trying to rate an organization. If Moody's were going to go into Coca-Cola or General Electric and try to give a bond rating, how could it do that if it only had the financial information associated with 2 out of the 5 operating divisions? I would encourage you all to think about the applications you're building or buying in a similar fashion. How can you truly get a good understanding of the risk in that application if you're only scanning or rating or reviewing the stuff that you have access to? It's a really important question, I think, when you think about the liability issues that are involved. And so this slide just breaks out, and we'll send this presentation around. This slide breaks out basically 2 types of risk. It's a very simplistic view of the world, but I think it's fairly telling that you have risk coming into your organization from third parties, whether you're purchasing application development services from a different geographic location, whether you're buying off-the-shelf software from well-known or not-so-known software vendors, whether you're pulling down open source, that code is containing risk, good or bad, that is coming into your organization when you take that step to go beyond your 4 walls. The other source of risk is internal risk, and that's a different type of risk where you may not have secure coding expertise. And for the most part, unless you're one of very few individuals, it's very difficult for any developer, regardless of how good you are, to truly be able to think about writing good functional code and writing secure functional code. It takes a very, very special and rare individual to be able to do both those things, think about the use case and the abuse case in the same environment. Other types of risks that exist are central security teams. So as we all know, Microsoft has made great strides in securing their products. If you look at the amount of time and effort and resources they invested, it's quite significant. Most organizations, even if you were to go to a large financial institution on Wall Street, have some of the best and brightest security minds. Many of you may work there, but there's not enough of them. You can't scale across a globally distributed organization. So there's an element here of scarcity of security expertise for sure. Then there's malicious insiders that obviously contribute to a lot of that risk. I think we all know, particularly in this room and beyond, that anyone really can get a backdoor in an application and obfuscate the best of QA processes. It's fairly simple to do that. And so to get a little bit more to point around the discussion today, why have independent software assessments been so difficult to achieve? And you step back, and it really kills me when I hear a lot of the tools providers in the marketplace say, that's insecure code, it's really the developer's fault. They don't know how to write secure code. Well, I mean, granted, I think there's some education that could take place, but again, I go back to the point where it's very, very difficult to do that. And even if you could train developers to go write secure code, would you really want to do it? I was just interviewing someone for an office manager role. And, you ask the tough questions. You say, do you like filing? Yeah, they can file. They don't like doing it. So most people don't like doing testing unless you're a testing professional. And it depends. I don't want to make it's not a black and white issue, but I think there's an element here that really begs the question. This isn't necessarily a secure coding problem, because you can write secure code. It's not necessarily a developer problem. But really, when you step back, to me, this is an industry problem. Why is this industry a $1 trillion industry and no one knows how secure the code is? Well, I like to use these examples. Well, the first example is, would you ever buy a washing machine or some sort of manufacturing product if you didn't know how it would perform? This example is a rating from the energy guide that's used for washing machines. And it's pretty, pretty ugly, but pretty useful label that's on most of the things that I buy. If you look at software, in some other types of independent assessments, 2 examples here would be Coke and Pepsi. I could use another argument that says Audi and BMW. These independent assessments that take place in the grocery store on a beverage or on a racetrack by Consumer Reports with 2 cars, would they be possible in software? What is stopping that? And I believe the fundamental issue is around the way the industry works. The industry is based on intellectual property. And there's 2 issues with making your intellectual property available to third parties. One is that it can be pirated, right? So it's a huge issue. Symantec, my division alone lost $250 million a year to pirates. Huge issue. The second one is if you make your software available, your source code available, it's much easier to hack it. Word gets out. The blueprint for your software gets out. So the reason we're here today with an industry that's $1 trillion, no notion of security quality, isn't because software companies don't care. It isn't because enterprises don't care. It's because to date, the fundamentals of independently assessing software don't work because source code is the crown jewel of the industry itself. And so you go back to Coke and Pepsi, I guarantee you that Coke and Pepsi would never let anyone independently taste that beverage if they had to make the secret formula for Coke available to that tester in the grocery store. It just wouldn't happen. So I think we need a new paradigm in the software industry to truly bring insight into how applications are tested. This slide really just points out that it has been done before in other industries. If you go back to the 1970s, back to the car example that I started the discussion with, all of the security issues related with car manufacturing back in the 1960s were born by insurance companies. Car manufacturers said, it's not our fault, it's the drivers of the car. They can't drive well, they get in accidents. And so what happened is, consumers would buy cars, they'd get in accidents, and the insurance companies would subsidize it. Well, as the 70s went through and progressed, and early in the 80s, the insurance companies said, that's not really true. These car braking systems are faulty. And what they decided to do was come together, exert their influence, and basically say that we're not going to insure cars if they don't bake security in. And so that car recall that I got last week, 100% of the costs associated with that recall were borne by Jeep, no insurance company. And so you start seeing similar things starting to happen in the software security space, where large organizations, particularly financial institutions, are starting to come together and starting to build into their third-party procurement and assessment processes security metrics for code quality. Why should they pay any longer for patches that relate to security defects in code? Is there an opportunity to assess that code before they purchase it and deploy it in that application? It's a really important question to ask, and you're starting to see financial institutions do that. The flip side of that is, on the other end of that procurement decision, there's a software producer that is building code that needs the same sort of metrics to determine what's appropriate for that application before they ship it and subject it to that assessment. It's almost as if you're going to prepare to get common criteria certified by the government. Wouldn't you like to know how close you are to even getting certified before you go and approach that government organization so they don't waste your time and money and churn? And so there's a real need for this, not just with the enterprises who are purchasing software, but similarly with the developers that are trying to develop software to a certain security quality. And really, I think we need to think about this as not being necessarily an enterprise problem or a ISV problem. It really is a supply chain problem. How do we collectively come together to get a set of independent metrics that work both for the enterprise and for the producer of that software? It can work in the software industry. Microsoft's a great example. 5 years ago, and I feel comfortable not talking about Microsoft now that I'm out of Symantec. I must have said Microsoft's done a great job on security 100 times. It was almost cathartic over the past year because at Symantec, obviously, we were struggling with our own issues with security. But Microsoft has done a fantastic job over the past 5 years to bake security in. Michael Howard, Steve Lipner's organization over there is really taking great strides to make sure that the right process, procedures, and even going to building their own tools and methodologies, everything from threat modeling all the way up to security testing and the final security review is secure. Long way to go still. I think everyone recognizes that software never will be 100% secure, but they've wrung a lot of risk out of their new products and applications that are coming to market. Now, most organizations don't have that same wherewithal, and some don't even have the same motivation, so we need to figure out a cost-effective way and a set of metrics that work for the masses. But I think it's fair to say that if Microsoft can do it, when there's a will and a way, other organizations should be able to do it if it's cost-effective and easy to implement. So before we get into the metrics discussion, just to sum up, why is it so difficult to even have metrics in the first place? One is that they don't exist in the security space. There is no agreed-upon set of metrics today. Two is that the source code access, particularly as it relates to the nested supply chain, is a really, really difficult problem. Again, go back to that Moody's issue. If you can only rate 2/3 or 1/4 of the organization, similarly, if you can only rate 1/3 of the application, is it really an effective risk rating at all? Three is that vendor self-certification really isn't sufficient. You know, many organizations are using tools, and I think it's a step forward to use your own tools and say, hey, I used a tool and produce a report, but you really can't have a fox guarding the henhouse scenario. And in many cases, and I have personal experience with this, developers may game the system for various issues. Maybe it's an enterprise institutional issue where they have MBOs. Maybe it's just the pressure of meeting ship deadlines. But in many cases, you can turn off and turn on various components of tools and configure them differently. And so I think that it's a very real issue that you need to have some independent third-party testing organization to scan code. And then lastly, this is a reality of the software industry. Manual code reviews, despite how good they are, take a long time and are expensive. And obviously, humans can't look at and assess binaries. And so I think there's some very, very critical issues that are facing the industry right now as far as getting independent assessments. So from our perspective, what is needed? And again, I'm speaking a little bit from Veracode's perspective, but other organizations will come to the fore to rate software. And the reason that I bring out these design points is that Veracode, in and of itself, was a binary tool. We fundamentally made the decision not to bring it to market as a tool, but as a service to try to provide a capability to rate software. Now, we are not the source of the ratings themselves. We provide the capability to rate and leverage other industry standards, as we'll talk about. But some of the things that are needed to be able to do it are looking at the entire application and be able to go through 100% of the code base. It's got to be cost effective. There has to be vendor motivation to do this. If the vendors don't agree to go along with the rating, they're never going to make their code available to be rated. You have to respect the IP of these organizations. And then lastly, the enterprise has to be sensitive to the state of the software industry. It is unreasonable for large enterprises to ask software companies to turn their software development lifecycle upside down to go fix a flaw that may be debatable on how exploitable it is. Like, software companies have a business to run. They have to make money to produce the software. So there's got to be this element of partnership between the enterprises that want to find out how secure the code is and the software providers that are allowing that assessment to take place. So quickly to go through what a potential service would look like. In the center there, you have a third-party assessment organization. On the either bookend, you have the enterprise that is a requester of that assessment, and then you have the ISV that is the subject or target of that assessment. And it really requires a collaborative approach across both the buyer and the producer of that software. The third-party assessor would essentially conduct a set of tests against that code. And Chris Wysopal, our CTO, likes to use the example of blood tests, where you have a doctor who is working with a patient, and that doctor gets a blood sample, pretty simple to do, and then submits it to some lab. And even though that doctor is really smart, typically a doctor has no idea what's going on behind the lab. He knows a bunch of tests are taking place, but doesn't really understand the equipment and how it's working, certainly doesn't understand the cost structure of how those tests are conducted. And in some cases may or may not be able to interpret all the results. But he knows that if he submits a blood sample, it's going to come back with a scorecard. That's really what we're trying to get here, where we really shouldn't rely on the enterprises or the software company to understand or have to bear all the costs associated with that assessment. But there has to be some independent third party that is doing that and doing it cost effectively to make this work for both players. And so in this particular model, this is obviously a genericized view of Veracode. What happens is, depending on the application, you would submit your binary application and then schedule a bunch of tests. Could be a static test, could be a dynamic test. You could actually do fuzzing against applications, but a set of tests should be conducted that then go spit back a result on the security quality of that application that is both understood by the enterprise and is able to be consumed by the ISV to go remediate that application. And it's very important that it's based on industry standards. And this is where Veracode steps back and leverages the work that's being done by many of you in this room. When I was at Symantec, and I guess I'm learning from some of the operational scars that I have, I got burned significantly by this thing called spyware. Symantec had its own threat classification system. Twice a year we release a Symantec threat report. It's picked up by all the news organizations and various people. I used to be one of them, used to get on the TV screen and do 30-second snippets around how bad spyware is, how many worms are out there floating around. When spyware came along, it's like the old adage, if everything looks like a, if you have a hammer, everything looks like a nail. Spyware is so fundamentally different than worms and viruses that the hardest problem Symantec had with solving the spyware problem wasn't a technical problem, it was a scoring problem. How did spyware fit into the definition of viruses and worms, and how should we score it? How bad is it? Well, it was really, really bad, and it had nothing to do with anything that Symantec was doing, quite honestly. And so when I came to Veracode, we said, let's not worry about what Veracode does well or doesn't do well. Let's take an industry-based approach to this, and let's go find various metrics that the industry players are already using to score security vulnerabilities. And this was really an important model, and we relied on essentially 3 independent organizations or metric bodies to help us with this. The first is CWE, the Common Weaknesses Enumeration, and we relied on this organization that's sponsored by MITRE and others to define all the possible programming errors that could lead to security vulnerabilities. And so essentially the taxonomy of all potential security flaws. Veracode does nothing to deal with this. We contribute to it, but it really is an industry-wide effort. The second one is CVSS, the Common Vulnerability Scoring System. And this was important because this is a generally accepted way to score security vulnerabilities. It's used by CIOs and CSOs when they decide which patches to deploy to their systems. It's used for the most part by all of the major ISVs out there to determine the security and the severity and the priority of patches when they recommend to their customers which one they fix. The third model out there is something from NIST, which is NIST assurance levels, which basically say, depending on the application you have, it's more or less important to do more testing. An example would be a Boeing flight control system would be a really high assurance application. Life and limb is hanging in the balance. And so you've probably seen recently Boeing had some issue with their new architecture. That brouhaha in the press wasn't saying that Boeing's new architecture is insecure. It basically said that the new architecture could potentially be vulnerable. So you really should take due care, Boeing, when you do the testing on that application to make sure that you've wrung as much risk out of the system as possible. You would never take the same time and care in testing to a back office application that manages the lunch menu and isn't web enabled. So I think there's this notion of assurance levels with applications that are really important that essentially dictate you should do different things to different applications because not all applications are created equal. And so it's important for any organization, whether it's Veracode or others, to rely on industry-based metrics and that we don't create our own scoring model that will take years to be broadly adopted in the marketplace. And so if you look at the bottom of the slide, just quickly to walk you through how, what our approach is, and again, it may be just one of many, but it's very intuitive, very straightforward, where you bring an application to the table, you basically define how important it is to you, whether it's based on the NIST-based standards or different definitions of business criticality. And as you define that, Veracode makes recommendations on the type of testing or blood tests that should be conducted against that application. Here you see Veracode has adopted a 3-letter scoring model, very similar to a Moody's approach to scoring. Each letter represents a different type of test that's been conducted against that application. And so as you do more tests, you wring out more false negatives or you identify more potential programming errors based on the different nature of those tests. It's almost so intuitive that it makes too much sense. Why isn't anybody doing it in mass today? Well, the key here is that this is done against binaries and not done against source code. So you send the binaries and you do multiple tests against it. And you end up with a 3-letter rating that allows internal producers of software to determine how secure the application is before I ship, or it allows an enterprise to go determine how secure this application is before I purchase it. This is a little bit more detail that you can look at later around how the scoring model works. And I think the important concept here is that there has to be some sort of sliding scale for applications. You could purchase an off-the-shelf application that doesn't have a web front end on it and say let's say Goldman Sachs purchased it and said that's never going to be web enabled. The risk profile of that is different than Morgan Stanley, who purchases the same application and puts a web front end on it and exposes critical customer data. So the same code can be used in different contexts or deployed in different contexts. And so because of that, you need to have a somewhat flexible model on how you actually rate software. And what this is meant to depict here is that as you move from down the lower left-hand quadrant, very low, to very high, we should hold vendors and enterprises should hold their own development teams to a higher level of standard and care as it starts touching things like personally identifiable information, credit card information, back office systems that are transacting. And so you do need to have a higher level of security based on those applications than, again, you do on a lower level application. So what are some of the methodologies or components of a good testing infrastructure? From our perspective, we really should run a battery of tests. If you look at the key categories of application security testing methodologies today, it runs from white box, obviously, where today largely discussed around source code tools. Humans obviously fall in this category as well, where you have good insight into the system and how it works, and you conduct testing in that regard. You have black box, which typically is also called dynamic analysis. You have folks like SPY and Watchfire and others in that category, where you don't have insight into how that application is working, and going and doing testing almost as if you were an attacker and trying to replicate attacker's behavior. Then you've got manual analysis. And so it's really important that you look at all of the programming flaws out there. There really is no silver bullet. Veracode will be the first one to tell you that. You need multiple testing techniques in the loop to do a really good job at high assurance applications. You may not need that for low assurance applications, but certainly for your business critical applications, you should be doing static testing. You should be doing dynamic testing if it has a web interface to it. And in many cases, again, if you're a Boeing 747 or a very critical online banking application, if you're a financial institution, you should have a human checking that as well. And so it's the interactive nature between these types of tests that allow you to wring out more and more risk the more you use or the more tests you deploy against that application. This is a graphic that captures that same sentiment, where if you start at the bottom, we have something here that says the bottom axis is cost and CWE coverage. This is a way that Veracode thinks about this. And essentially, as you move from the left-hand side of this slide, and again, this would be interesting for you to review. It's a lot of information to consume off a slide like this if you can't see it very well. But as you move from the left, which is very low assurance applications, to no cost to test because you're not testing it, to the right, to a high assurance application, what you're doing essentially is conducting more tests, incurring more costs, and wringing more risk out of that application. It's a fairly simple concept. And so as you go from the bottom stack the green and the blue bars there represent different types of tests. The first level of assurance may simply just ask questions. Are you using source code tools? The next level may be asking for their binary and doing a complete end-to-end analysis statically on that binary, which includes not just source code, but third-party libraries in that. The next level of test may say, I'm going to run a pen test against that in an automated fashion. The next one may be, I'm going to go hire a human to go conduct a pen test, to go make sure that it can go through all the programming flaws that could lead to security vulnerabilities in the business logic of that application. And the final test may be, if it really is Boeing 747, I would hope that they do manual code reviews against all their applications. And so this is just a framework for you to think about, whether you're developing code and testing code internally or purchasing code, what sort of tests should you hold either your internal development teams or external suppliers accountable to make sure that have been conducted against that application. Some of the benefits of independent trust reviews are obviously third-party validation. You really can't self-certify. So if you're subject to PCI, Sarbanes-Oxley, HIPAA, obviously that's a very important element to it, is having some third-party test that for you. In many cases, there are organizations out there right now, the security boutiques do a lot of this work, Virtual Security, ISEC Partners, Leviathan, they're all doing this type of work for software companies and enterprises today. Reduced operational costs. If security testing isn't your core competence, why not just outsource it, right? Why incur the costs associated with software, hardware deployment, and not tap into a shared infrastructure to get that testing done for you. In addition, hosted infrastructures like a Veracode have the ability to have much richer data sets and security intelligence because they're able to glean from all the applications they're looking at the latest and greatest security threats or coding constructs that may lead to a security threat. It's a very important concept. Then lastly, which I discussed, path to compliance. Again, if you are looking to get that checkbox for compliance purposes, having a third party look at that, whether it's a consultant or a service like Veracode, satisfies that requirement. So before we take some questions here, just quick conclusions on how to potentially start getting some sort of sense or arms or some framework in place to do application security testing. First step, obviously, is be pragmatic. You can't test everything. Pick those things that are important to you and make sure that you're applying the right techniques to them. Criticality of your applications is absolutely essential. You can't test everything. Start with the most important and work your way down. Leverage industry standards to make sure that you're able to truly, objectively look at code sourced internally and externally. You got to hold yourself or your vendors accountable to the same level of standards. The power to this is not just being able to do comparisons, but the business advantage is being able to make business decisions coming out of that. So for instance, if you know that your team is particularly good at writing Java applications versus C++, maybe you send some of that development work offshore. Or maybe you impact your hiring decisions and make sure you get more C++ capabilities internally. Maybe you're outsourcing all of your application development and you can tell whether Wipro or Cognizant or Infosys is doing a better job in one particular language over another. So the comparative benchmarking is really critical there. And to do that, I think leveraging CWE and CVSS and others for those metrics is really critical. Understand the source of risk and make sure that you truly understand this is not just about source code analysis, but looking at the entire application in its entirety and where the weak links could be between the tiers in an N-tier application, for example. And then 4, work with the extended supply chain to make sure that they are able to produce visible proof to you as a purchasing entity that the due care has been taken on those applications. There's no reason for enterprises to absorb security risk, unreasonable security risk from third parties. I think it's really critical that we recognize that the ISV community, particularly some of the larger software providers, are doing everything they can to improve their products, and there is visible proof that that in fact has taken place. As it relates to organizations that don't have the same means, it's important for us to keep in mind that we need to be a pragmatic way to ask them for visible proof that the proper testing has been done against that code, but at the same time make sure that the enterprise ask is consistent with helping that organization make money, because you're never going to have a perfectly secure application. With that, I'd love to open it up for questions on any aspect of whether it's the independent assessments or sort of the application security testing space.
We do have a mic, so if you have a question, let us know. Any questions?
Hi. The framework that you propose obviously makes a lot of sense from an enterprise perspective, and I understand it's your business. But looking at this from a more esoterical perspective and focusing on point number 4, what industry pressure is there, real, to get the vendors and hosted service providers to come to the table with fully independently tested applications? This is, we're trying to fix a problem that exists because the quality, when we get down to it, isn't baked into the products right now. Mm-hmm. I mean, in an ideal world, the vendors would have a fully tested product and say, it's been tested, it's been approved, here's my seal of approval, you can trust the product. Mm-hmm. So we don't have to incur the cost of the time to go forward to, or the risk, going forward with new applications.
Yeah, so we're seeing it happen today. And again, I just speak from Veracode's perspective. Actually, I should give you an example that's non-application security. So when I was at Symantec, mid-cycle, mid-budget cycle, I had Best Buy come to me and say, you know something, we're moving to RFID tags. And I said, oh, great, we'll do it our next budget cycle, we'll budget for that, and we'll go and comply with that. They said, no, we're going now. I said, what do you mean? It's going to cost you $2 million, and you have to do it, or else we're taking your product off the shelf. So I found $2 million to do it, right? Too much of my business went through Best Buy. We're seeing that in this particular space, where largely because the source code issue has been taken off the table with new innovations like a Veracode, where all it takes is a large enterprise to say to that vendor, we're not going to purchase your product if you don't get independently tested. I've seen it happen in our engagement with the enterprises. What enterprises need to do, and to keep in mind, is that it's got to be reasonable. It's got to pass the giggle test. And where I say that is that it's not unreasonable for an enterprise to ask a software provider to fix severity 5 and severity 4 flaws before they purchase it. When it comes to severity 3s and 2s, and there may be some debate around, is it exploitable? Because severity really isn't that interesting. It's really around how exploitable is the flaw. Enterprises have to be reasonable and say, okay, I can see how there may be some discussion that they may not be critical today, but are you going to make a commitment over the course of the next 12 to 18 months to wring that risk out of your system? And I think in order to do that, suppliers like Veracode and others, quite honestly, have to make it very easy and cost-effective to comply with an enterprise request.
Well, my experience, and I do a lot of due diligence work right now when we're looking particularly at hosted service providers and software. It's the exception rather than the rule. I mean, I always ask, have you been pen tested? And can you show me the results? And they may come back and say, well, we've had some of our clients, some of our customers have pen tested, but we can't share that with you. You know, okay, well, I can pen test it and I can put that into the contract and then it can be part of the procurement process, but why should I have to, I guess is my point. Shouldn't the vendor come to the table if it's dealing with confidential and sensitive information? I mean, shouldn't they be coming to the table with something that says, yes, you know, I got a SAS 70 over here, but I also have an independently tested seal of approval that says you can trust my service. Yeah,
no, I think you're 100% right. You know, so if you think about it, if you look at Microsoft and the strides that they've taken to improve their products, the market really reached a crescendo, right? Where, you know, large enterprises and consumers in this thing called Linux and Apple were out there, where Microsoft said, listen, our business is around providing secure code to our customers. We have to do something. So they did it. If you see a Home Depot or a Boeing stand up and essentially say, we're going to rate software before it enters our ecosystem, that is a type of ripple effect that I think will jumpstart this type of industry. Right? Because outside of the Microsofts, the Oracles, the SAPs, the top 10 software companies that are investing the resources to do this, the vast majority of, you know, software company number 15 down to 500, you know, will not do it. A, because either they can't afford it or it's not their core competence, unless the purchase of those software require it. So I think that it hasn't happened to date because it's been unreasonable to ask software companies for source code, although it happens on a spotty basis. But the cost of breaches are so high that you will see, I predict in the next 12 months, major organizations standing up and standardizing on services like Veracode to scan third-party code coming in. Once it happens, then it's just a matter of time, because then it becomes a marketing exercise, and you're going to have to compare products. And I do think that there's a role for underwriter labs types of capabilities if the right industries come together and require it from the software providers. But again, the software providers need an easy way to do it. The answer can't be, okay, I need to go buy a tool, go through a 6-month procurement process, implement it, and then still go get a third party to come in and assess it. It's too onerous.
Hi, Matt.
Hi.
Given that, you know, 5 or 10 different pen testing companies might come back with 5 or 10 literally different reports, what would be the minimum or maximum, I guess, acceptable threshold level of false negatives coming back from an independent rating service in order for it to be truly effective?
It's a great question, and there is no definition of what that would be today. In most of the industry today is focusing on false positives, as you probably know, and not even discussing the false negative issue. You know, my view is that it really comes down to what is the acceptable attack surface, right? And I think that false negatives should be higher or lower based on sort of the I guess the current prevalent way that the hackers are leveraging those attack vectors. So I'll give you an example, and this is one of the reasons I think that Veracode is an interesting animal, is that back in 2005, when I left Symantec in 2006, 15% of my customers were still on Windows 95. That's 200 million, I had 200 million customers, so it was about, 15%, it's 30 million customers that are out there. Now, the risk profile, the security of Norton 2006 was so fundamentally different than Norton 1995. Now, cross-site scripting, if you were to take that as an example, something that's top of mind today for every organization, particularly in web-based applications, 7 years ago, it was still a known vulnerability, it just wasn't exploited. So 7 years ago, I would say that the false negative rates could have been very high. I really would have been that concerned, quite honestly. Today, I'd have a very fundamentally different answer. And so to get to your point, I mean, I think just on an absolute basis, I think if you were to get to something like, 30%, 20% false negative rates, it would certainly be deemed market leading today, just given my understanding of the various testing methodologies that are out there. That number may or may not be acceptable tomorrow as risk profiles change. And so I think it's really critical, again, to have a commitment by any tool or service provider to wringing false negatives out of the system. False positives are, we like to say at Veracode, false positives are really interesting to keeping customers loyal. Right? When your developers are working, don't waste their time. Make sure you have low false positive rates. False negatives are important for winning business. Right? That's where the trust with the enterprise who's signing the contract says, okay, these guys are doing a good job of getting false negatives out of the application, and they're making a continual commitment to do that, which is important because of the temporal nature, the ever-changing nature of the threat environment. So it's a long way to say it's a moving target, but that has to become where the industry is focused on now, as opposed to just the false positive discussion that's out there. Okay, if there's any other questions, I'd be happy to answer them later on. Thanks very much for attending.
Thanks, Matt. Very quickly, before you leave the room, if you're going to a different talk, please pick up a feedback form over by the water cooler over there. It's going to be very important for us, especially as our first-year conference, to get good feedback on our speakers and how we're doing. You don't have to fill it out right away, but please fill it in while your memory is still fresh. There's a box out at the registration desk to collect all the forms. Also, if you plan to stay on the application security track, that continues upstairs in the Cambridge room with Bob Martin from MITRE. It's up the elevators to the right. In this room, we'll be picking up with the business and security track. Thanks. Second floor.